Good morning, and thank you for joining us today. Today's webinar is Global Harmonization of the QueChERS Method through an Automated Workstation Platform, presented by Tyler Trent. We will be taking questions throughout the presentation, and we will address them at the end, so feel free to submit them throughout. Okay, I'm going to turn it over to you, Tyler.
Thank you, Shelley. Good morning. Welcome. My name is Tyler Trent. I'm the application specialist here for Teledyne Tekmar for the Automate Q40 QueChERS platform, extraction platform. Today we're going to have a webinar entitled Global Harmonization of the QueChERS Method through an Automated Workstation Platform. So let's get started. Overview. So kind of what we're going to be talking about today is QueChERS, the method that everyone knows, but the method that everyone loves to modify. The Automate Q40, which is the Teledyne Tekmar's automated QueChERS extraction work platform. And we're going to travel across the world and look at 3 different results for the Automate Q40 that we did. So we're going to start off here in the United States and look at the laboratory study that our United States Food and Drug Administration did out of College Park, Maryland. Then we're going to head over to Europe and we're going to look at the results that FARA did, so the Food Environmental Research Agency out of York, UK. And then we're going to head down to France, down to Marseille and Montpellier to look at the SCL laboratory and the results and work that they did on the Automate Q40. So everyone knows what QuEChERS is, so we're going to have a quick, brief overview. So QuEChERS stands for Quick, Easy, Cheap, Effective, Rugged, and Safe. It's a simplified shake extractions. It was designed for fruits and vegetables and for pesticide residue analysis. But over the years, the method has been modified and will continue to be modified to extend to different compound classes and different commodities. The first method was published in the Journal of AOAC in 2003, which is basically the original unbuffered method. And since then, there has been 2 spin-offs using from the AOAC 2007.01 and the EN 15662. So we have 2 different styles of methods. One uses a citrate buffer, and the other one uses an acetate buffer. So what is QuEChERS? So we have to have a homogenization of the commodity. We will add the extraction solvent. We will add the spikes and internal standards if we're doing QC samples. Addition of salts and buffers for partitioning coefficient. Addition of acetonitrile. We're going to basically do a shake vortex. We're going to centrifuge. Then we're going to clean that aliquot up by using dispersive solid phase extraction cleanup material. Then we're going to do a preparation of the final sample, so we can either add acid to preserve it, or we can do a dilution or a solvent exchange. And then we're going to finally analyze by some method of chromatography, GC or LC. So these can range from GC singles to GC triples, and the same thing for LCs, but typically it's LC-MS-MS. So this is the first step of QuEChERS, is a homogenization point. So basically, the better we homogenize, the better we should have, more extraction efficiency we should have. So we're going to add our solvents and salts. We're going to shake. We're going to centrifuge. Next, we're going to go through the cleanup process using different types of material. Depending on your samples, the DSPE material can change. The typical DSPE material is magnesium sulfate, PSA. But if you're looking at something that has a lot of chlorophyll, or a very green sample, I should say, then we can incorporate carbon cleanup into it. Or if you're looking for something that has a lot of fats, such as avocados, we can incorporate C18 in there to help grab the fats. Then we're going to shake that once again. We're going to centrifuge. Then we're going to prepare the final sample, and we're going to analyze by some sort of chromatography technique. So here's the original QuEChERS method that started off in 2003. As you see, a 10-gram sample for the high moisture commodities. Then if you're doing a low moisture sample such as grains or dried fruits and vegetables, you might need to adjust that anywhere from 2 to 5 grams, and then add water for hydration. Basically, it's a standard partitioning with magnesium sulfate and sodium chloride, 10 mils of acetonitrile, and then we'll clean up using magnesium sulfate and PSA. But as time evolved, we found that certain compounds behave differently when we add different types of buffering salts. So the AOAC 2007.01 QueChERS method basically increased the sample weight to 15 grams, increased the sample extraction volume to 15 mils, and added acetic acid for the extraction. But we also changed the salts and used sodium acetate and magnesium sulfate instead of the sodium chloride. So this will help with certain commodities, certain compounds. And the DSP was also scaled up to 8 mils instead of 6. But for overseas, the EN 15662.2008 method was done. It kind of followed the same method guidelines as the original unbuffered, but what you see is different is they use citrate buffers instead of acetate buffers like the AOAC, and they found this works better for certain compounds also. So what is the Automate Q40? Automate Q40 is an automated QueChERS extraction platform. It's a revolutionary system specifically designed to optimize and to automate the QueChERS workflow. It offers a comprehensive solution. So what we like to say is we'll get you from homogenate to the final extract. So just a little review about the system. Its capacity is 40 samples. It is designed to run the AOAC, the EN, and the unbuffered method straight out of the box. The system is capable of method customization. So if you would like to add more solvent or different types of solvent, you can have free range to add different types of solvents for different types of extraction. So it's just not only made for the QueChERS extraction. We can do QuIP and we can do other extractions along with it. The system handles the 50 milliliter and 15 milliliter conical centrifuge tubes. So what's not automated with this system? Well, first you still have to homogenize your sample. You still have to weigh your sample into the tubes. You still have to place the tubes into the trays. You still have to add the DSPE tubes and the final extraction tubes, and make sure you have all your consumables loaded into the unit. So what the unit does for you is addition of extraction solvents, addition of spikes and standards if need be, addition of the extraction salts and buffers. It will shake the sample. It will also vortex the sample. It will centrifuge. It will perform the DSPE cleanup, and it will prepare the final extract by adding acid to preserve. And we also have what we call vial vision, which is a secondary check to make sure the volumes are correct throughout the extraction. So as you see here, here is just a complete view of the Automate. As you see, there are 8 removable sample trays that gives you a total of 40 positions. The shaker will shake at 420 oscillations per minute. The vials are moved around by an XYZ robotic arm with a gripper. We have 2 syringe drives. We have a larger 25 milliliter syringe drive to do the extraction solvents, and we have a smaller 250 microliter syringe drive to do the internal standards and spiking solutions if need be. Centrifuge meets all method criteria for EN and AOAC, and also comes out with an out-of-balance sensor for safety control. The sample shuttle and capping station on your right-hand side, it controls the vial capping and decapping. It's a collection point for solvents and standards and salt addition. The salt dispenser will hold a 2 kilogram jug of pre-mixed QueChERS extraction salts. What we do with our QueChERS extraction salts, we make sure the particle size are the same, so we don't get no channeling or separation out. So that's why we can do a big 2 kilogram mix. What you cannot see is the vortexer. It's hidden behind the shuttle. Basically, it will vortex at 3,000 RPMs a minute, RPMs, for complete blending of the standard to the sample. Then also the system is controlled by a touchscreen tablet that is on the front. So right here is a video of the QuECHERS system that's just going to walk you through exactly what it does. So it's going to pick up the first vial. It's going to decap the vials. It's going to open them. It's going to add the solvents. It's going to vortex so we get mixture between our solvents and our standard and our commodity. We're going to add the salts and buffers. We're going to shake the sample. After the shaking, we're going to centrifuge to separate the organic layer. We're going to use the camera, the VialVision camera, to go through and check the volume. Then we're going to use the ADP, which is an air displacement pipette, to transfer the sample from the extraction tube to the DSPE. Then it's going to perform the same steps over again with the shaking, centrifuge, VialVision, and pipetting to the final extract, so we're ready for analysis. So right here is just a closer look at the Automate Q40. On the left-hand side, you see the vial trays. So the larger tube, the 50 milliliter tube, is your sample extraction. The tube in the middle is your DSPE cleanup. They come pre-packed, pre-filled with your DSP of choice. And the final tube is just an empty tube. The third place is where the final aliquot is collected. Behind, you can see that the shaker, two-position shaker for both 50 and 15. Then on the right-hand side, this is where all the work is truly done. As you can see, the arm has the air displacement pipette on it, and it's able to transfer the liquid between the vials. You have your capping station, your salt addition. Then in the back, you have 3 amber vials that are your standard, internal standard spiking solution and preservative solution. Your 2 syringe drives, your larger syringe drives for your solvent, and your smaller syringe drive is for your spiking solutions or preservative. So it comes standard with the AOAC and the EN method preloaded on to the system, so it can come straight out of the box and perform the method of choice. But like I said, if you would like to optimize or to do method development and change around parameters, you have every right to do that, and we allow you to change your solvent volume. You're allowed to deliver up to 40 mils of solvent. You can shake anywhere from 0 to an hour. You can centrifuge 0 to 30 minutes. You can transfer as much as liquid as you would like to with the ADP. So we do give you optimization parameters so you can customize. So let's look at our first laboratory study. So the United States Food and Drug Administration out of College Park, Maryland, evaluated the Automate Q40 for this study for us. So what they wanted to do there at the US FDA was compare the extraction performance between the Automate Q40 and a manual process. They used a modified AOAC 2007 unbuffered method. The samples in the study were analyzed using LC-MS. So for this, 4 commodities were chosen to represent a wide range of complexity. So we had cabbage, Valencia oranges, raisins, and purple corn flour. So as you see, we have 2 commodities that have high moisture contents and 2 commodities that have low moisture contents that require hydration. So right here for the laboratory study, the extraction was performed. So they basically cryo-grind and homogenize commodities. They ended up pre-spiking on top of the commodity and let sit for 15 minutes. They placed the samples in the Automate Q40. The system then added 10 milliliters of acetonitrile, an internal standard, and vortexed. It added the QuECHERS salts, the unbuffered QuECHERS salts. It shook and centrifuged. Then it transferred 5 to 15 milliliters into the DSPE tube for to be shaken and to be cleaned up, to be shaked and cleaned and centrifuged. Then 100 microliters of the ACN top layer was diluted with the ACN buffer and prepared solvent-only and matrix-matic standards for analysis on the LC-MS. So basically what we do for this is the whole complete extraction process. Once the samples were placed in and the 100 microliters was transferred over to the final vial, was all performed by the Automate Q40. As you see, it performs a large portion of the QuECHERS extraction for you. So what we say is it likes to get you from the homogenate to the final extract. Here are the UHPLC parameters that they used. Pretty typical for pesticide analysis. And for this, they looked at 204 pesticides. As you can see on the right-hand side, the retention times in minutes. The last compound comes out at about 13 minutes. So we have 204 pesticides plus all the transitions in under 13 minutes. Here is just a MRM chromatogram for the solvent calibration standard. So right here is basically a comparison between the Automate Q40 and the manual extraction. The recovery parameters were set between 70 and 115 for this study. And as you can see, majority of the Automate Q40 extraction results fell within the optimal range. So relative error, so we're comparing the differences between each here. And as you can see, the Automate Q40 is really tight. It's below 20%. As we move on, we see now we're moving on to the Valencia oranges. Valencia oranges fall within the 70 to 120 for the 204 pesticides. You do have some outliers that didn't recover pretty well, but you see that for both manual and Automate Q40. As you know, there will be some problematic compounds, especially with Valencia oranges, since it is an acidic commodity. And you can look at the manual side to see the manual was approaching 115 to 120 for the recoveries. And the Automate Q40 was between 70 to 115 for a majority of the compounds. Once again, you can see the relative error is pretty tight. It's all below 20%. I mean, you do still have some outliers, just like you do with the manual process. Raisins, this is the first commodity that they had to hydrate. As you can see, it was kind of towards the upper end of the 115 for both Automate Q40 and the manual process. Raisins, for some odd reason, we had a little bit higher relative error here for the raisins. That's just the nature of the sample. Maybe they shook a little bit better, so on the manual side compared to the automation. But you can see that most of them fall below the 20% relative error. And what we'll see here is when we look at the statistical analysis at the end, we'll see the better comparison. Same here again with the purple corn flour, commodity that need to be hydrated. But for this results, as you can see for our relative error, most of the compounds were below the 20% again, and they compared very favorably to the manual process for this hydration commodity. So what we want to look here is let's look at the 10 ppb performance between the system and manual. So between the comparison is we had 80% of the compounds were similar for the cabbage, and 20% were different. For the raisins, we had a slightly lower number of 73% that were similar, and 27% that was different at the 10 ppb level, which we know is the MRL that we need to reach for most of the pesticides. 175 compounds were similar, so the 86% for the Valencia oranges. And then purple corn flour, we had almost 90% that were similar. And at the bottom, you can see the average across all commodities for the commodities for each 3 different levels. So recoveries for this demonstrated the Automate Q40's ability to successfully produce, extract the cabbage, Valencia oranges, raisins, and purple corn flour. Samples were prepared using the Automate Q40 and were statistically compared to the same samples that were manually extracted by an analyst. The automation of the QuECHERS extraction method was found to produce reliable results for spike samples, which compared favorably to the ones that were manually extracted. I'd like to give acknowledgement to the USD-FDA CIFSAN group, namely Kelly Simon, James Wittenberg, and John Wong, and Alex Krasinski. If it wasn't for them, this work wouldn't be possible. I just want to thank them for the support and hard work that they did for this. So now let's hop across the pond. We're going to go over to the Food and Environmental Research Agency of the United Kingdom up in York. So what they did here is just compared the extraction performance of the Automated Q40. They followed the EN 15662 2008 guidelines. Samples in this validation were conducted or analyzed by LC-MS. More than three commodities were chosen, but we're just going to show you a representation of three. So they ended up doing apples, lettuce, and oats. So 2 high moisture commodities and one commodity that had low moisture. They followed a pretty strict EN 15662. They did not modify it at all. Study was done on UHPLC-MS, HPLC. As you can see here, for 241 pesticides, that's at a 20 ppb calibration standard point. For these results, they're kind of hard to see for 241 compounds. As you can see, the spiked recoveries at a low and a medium for this commodity all fell within the results of recoveries that they were looking for according to the SANCO guidelines. For lettuce, as you can see again, we had the same results. Most of the commodities fell between the 70 to 120 guidelines for the SANCO documentation. Here we did oats. Oats had 3 validation levels just because they knew the oats were kind of problematic when they wanted to extract them, so they wanted to be really sure about the results and recoveries that they were getting. As you can see, when one compound did fall out of the 70 to 120, all 3 levels did. So it showed that they were problematic for that matrix. For this, they measured, as I said before, samples of the apples and lettuce and oats at 241 pesticides. They were able to generate spiking recovery studies for 0.1, 0.1, 0.2, 0.5 milligrams per kilogram. Samples were quantitated against their matrix max calibration curves. As you saw, some of the recoveries ranged from 25% to 134%. That some of the lower recoveries were the problematic pesticides that you see on daily routine work. The system demonstrated great precision. When we were looking at the 7 reps for each spike level, we had RSDs from 1 to 18%. And with this, it has to fall within the document, SANCO's 1257-1-2013. All of the results had to fall within to be valid for this, and it did. So what we like to do is send some special thanks to the Food and Environmental Research of FARA who took their time. This project was performed a few years ago, but if it wasn't for them, this project wouldn't have been possible without their support and hard work. So now let's venture down through the tunnel and go to France. So we have 2 units over there at the SCL laboratories, one in Marseille and Montpellier, France. Recently, this work was presented at the European Pesticide Workshop in Cyprus. So basically what they did was we found that QuECHERS, as you know in Europe, is a widely used extraction for pesticide residues. The last proficiency test for fruits and vegetables in the EU showed that 74% of the results stem from QuECHERS. So for this, what we wanted to do was we wanted to run the EU proficiency test samples along with laboratory fortified samples following the extraction method of 15662-2008 on the Automated Q40. So basically this test consisted of 2 already known EUPT samples. Then the samples in this validation were analyzed by LC-MS also. Here is the extraction parameters that they followed. They decided to manually add the water or the alkaline solution for acidic commodities manually. Then they place the samples into the Q40 and allow the Q40, automate Q40 to process according to the EN method. But as you can see, they vortex for 3 minutes, they shook for 3 minutes, because they believe the longer the shake is, the better the recoveries you're going to get from the incurred residues, which is true. So here are the EUPT sample results. So this was done on pairs. It is evaluated based upon the Z-score. So the Z-score, the closer you are to 0, the better you are. As you can see here for Boscalid, we had an evaluated Z-score of 0 because we were really close to the true value of the sample. So as you see, we have satisfactory ratings. As we move on to wheats, where we need to hydrate the samples, we were satisfactory in every one except for carbendazime. Carbendazime showed to be a little resilient, but it also did the same thing when they extracted it manually by hand. So also, they wanted to do laboratory fortified samples. So with this, they did a three-step validation test was performed on the laboratory fortified samples. So they looked at 10 recoveries with about 100 pesticides on wet and dry commodities, apples and rice samples, to control to monitor the efficiency of the system. 5 replicates of the same spikes fruits were prepared with blanks in between so they could check for possible cross-contamination in the system. 10 comparisons between manual and mechanical agitation on routine samples. So basically they compared manual shaking versus the automated Q40 shaking on 10 samples. It varied from fruits, vegetables, and teas to control the extraction, to look at the extraction efficiency of incurred residues. With this, some of the results weren't published in tables, so we have to go by what they presented at the EPRW 2016 conference in Cyprus. They showed excellent efficiency of the process of recoveries between 70 to 120% for 96% of the analyzed pesticides. So 96% of the pesticides fell within their performance guidelines. The reproducibility of the 5 replicate samples was quite good and had lower than 10% RSDs, and the RSDs for the internal standard were 3% or less. The reproducibility between the manual extraction and the automated Q40 process on real samples to look at the incurred residues in all cases were lower, had a variation coefficient lower than 20%, even for the low levels of the 10 ppb samples, which is quite good. So with this, we want to thank special thanks to SCL, who took their time to evaluate the QuECHERS unit, and they continue to run it for the everyday process in both of their laboratories, and for doing a wonderful poster for us down at EPRW 2016 down in Cyprus. If it wasn't for them, as I've said before, this work wouldn't be possible without their hard work and support. So, in conclusion, this is just going to be a quick webinar today to show the three laboratory studies that we performed. The automated Q40 achieved outstanding precision and accuracy in all 3 laboratory settings. It improves the sample capacity for the laboratory by allowing them to add more samples to their daily run, to the daily extraction. And it also reduces the likelihood of human error. As we've probably all seen throughout many presentations when it comes to sample preparation, that 70% of the error is made in the sample extraction or the sample preparation part, and not on the analyze side. So with this, it helps reduce the likelihood of human error, and also cuts down and allows for significant labor savings. With that, I know it's pretty quick, but I just want to thank you for all your time, taking your time out of your day for this. And if you guys have any questions, please let me know, and I'll be able to answer them for you.